is basically this integral now has meaning because we're differentiating with respect to x. And the cool thing about this formula, this is the formula that you want to memorize. And this is what I think is cool about it. I mean, if a formula can be cool, is that we're taking some function, some y equals function, and we're trying to find out the length of that y equals function. And the formula that tells us doesn't even have the function as part of the formula. Y itself isn't even in here. So you take the derivative and plug it into some formula which you take the integral of. Right? That's the weird thing about what's going on here, right? So they'll say y equals this, and you don't even use the y equals. I mean, you use it to find the derivative, and then you use the derivative in the formula. So know that this formula comes from the Pythagorean theorem, right? And you're just doing 1 plus the derivative, because that's what dy dx is. That's the derivative. And you're squaring the derivative, adding 1, taking the square root. That's how you find the length of your arc. If you want to find your arc length with respect to the y-axis, the tricks are the same, except you multiply top and bottom by dy, and you end up with the following formula. It'll be the square root of 1 plus, and instead of dy dx, we have dx dy squared, and it's a dy integral. So you basically solve for x in your equation and differentiate with respect to y. And then your bounds would be still from a to b, but those would be along the y-axis. So I'll put little subscripts here. So you're going from your bounds from along the y-axis. So it'll be f of a to f of b, I guess. Right. Yeah. Usually it'll have a different. In the context, you won't think of it as f of a, f of b. But that's the same. So it's the same formula. Those things are kind of rearranged a little bit. All right. So that's your arc length formula. That's what you want to memorize. Any questions? Okay, let's do a problem from the book. A lot of people, both classes have asked about number 18. So you want to do that? Let's do that one. Number 18. It tells us that y is equal to an integral of the square root, that's an x, of 3t to the 4th minus 1, I guess. Is that right? Yep. dt. And we're integrating from -2 to -1. So this is some curve. So they're describing the function as an integral. So it's hard to visualize this. You have to describe the. My point is, it's hard to graph this. You don't really even know what it looks like. So our integral, it tells us the bounds. We go from -2 to -1 of the square root 1 plus the derivative squared dx. So here's our formula. The only thing we need to figure out is what dy dx is, and we're good. So let's talk about how to figure that out. So dy dx is the derivative of the integral. Okay, so when I take the derivative of an integral, I have to use on some special fundamental theorem of calculus. You guys remember which one? Yeah, exactly. I give you a hint as to which one. First one, yeah. That's the one. Right. So, first fundamental theorem of calculus. And so, what do we do, Kyle? Hey, you just plug x in for t. So 3x to the 4th minus 1. And there's your function. But that's the derivative. Right, this is your derivative. Now, quick question. Suppose the x was actually a 5x. Then I would plug 5x in for t to get 625 times 30x, x to the 4th, whatever. But then you multiply by what? 5. Right? By y. What are you using? Chain rule, right? You take. It's because this is really times the derivative of x, which happens to be 1. But if this was 5x, you plug in the 5x and then times it by 5 by the chain rule. If it was x squared, you plug x squared in for t, and then at the very end multiply by 2x, because 2x is the derivative of x squared. You remember that? That's the first fundamental theorem of calculus. So it'll probably be on the AP exam in the multiple choice form. And it should be a question that you just can do in a couple of seconds. Yeah, like that. Yeah. All right, sounds good. So this is this square root is the derivative, so we plug it in to dy dx. So L equals the integral from -2 to -1 of the square root of 1 plus square root of 3x to the 4th minus 1 quantity squared dx. So it's very convenient that they gave us a function whose derivative has a square root, because then when you square the square root, cancels out. So we have -2 to -1, square root of 1 plus 3x to the 4th minus 1. And the 1's cancel out. And how do we handle the square root of 3x to the 4th? Any ideas? Think of it as the square root of 3 times the square root of x to the 4th. So the square root of 3 is a constant, so just take that outside the integral. We're left with x squared dx, because x squared is really the square root of x to the 4th. That make sense? Algebra-wise? Okay, everyone's cool with that? And this becomes the square root of 3 times x cubed over 3. That's the integral of x squared from -2 to -1, which is the square root of 3 from -1/3 minus 8/3, no, plus 8/3. Because I'm minusing the negative.
Yeah.
So that becomes 7 square root of 3 over 3. What are the units here? Units. It's arc length. Right? Length is just in units. So there's our answer for number, whatever that was, 18. Okay? Thank you, Sierra.